Back? Right, so Martin de Wit and I are both from South Africa. I am an evolutionary biologist and I work at Nelson Mandela's old university, the University of Port Hare. Martin works, he's a geophysicist and he works on the coast about 200 kilometers away from us. Martin and I do not speak the same language at all in science, and we have been working together since 2000. In 2000, I invited him to kick off a Madagascar symposium of mine at a systematics conference. In the time that has elapsed, in 16 years, we have learned a great deal, although not enough to solve the problem we started with in the first place. So I'm going to hand over to Martin. We're going to do a bit of a soft shoe shuffle here. And Martin's going to talk about his Indian Ocean side, and I'm going to talk about the animals.
Judith and I have worked together for 16 years and we have never ever agreed very much. And we're still trying to solve this problem. And I remember when I was a little boy, about 8 years old, in Utrecht, my parents made me do a duet with my brother, and it was a complete failure. So I want to warn you about these duets. My interest is in understanding and helping Judith to see what we can understand about the evolution of the Indian Ocean in terms of her problems that she'd like to solve in Madagascar. So just a brief overview. There's India, there's Madagascar, there's Africa. It seems that is, we've heard about this. I don't have to tell you much more about the distances. Here are the islands, Sierra Leone, Mauritius, Seychelles. They play a big role. These white things are continental masses. And I'll come back to that later. When I met Judith first, she told me about this unique problem. How do we get why are there lemurs in Madagascar and nowhere else? And I said, well, we know the answers to that. We can give you a physics answer. It's a very simple answer to solve. So I want to re-emphasize this issue here of how these animals got to Madagascar here. And we were able to show, just like Paul did very quickly, that mathematically it's very difficult to get these things there over the time period that you have. So that was an easy one to solve. We can't do it to the Comores because the Comores are not there at that time in the Cretaceous. They're very young, and the only place where one might be able to go across here is called the Davy Ridge. And the Davy Ridge, we know from drilling from the oil companies, has been above sea level from time to time, so episodically. This is what we essentially know. There's the age there on the top, on the left-hand top. This is essentially what the geophysicists said. Well, we have a good idea of how Gondwana broke up, and I'll play this a couple of times quickly. We ought to be able to use this data to solve your problems. And I set out then to do that in 2001. By the way, if you're interested in this, this is actually done by a Dutch geologist. He lives in Delft. Rif-Raf. If you're interested in it, you should go and visit him. But you can see the essence here, Madagascar, India, coming apart there around about 460 to 140 million years. And once you're away 140 million years, you are no longer able to walk across. So I'm going to hand over. I will come back to these difficulties that we have in the Indian Ocean, understanding that. But I'll hand over to Judith to tell you what the problems really are.
Okay, we haven't made a huge amount of progress on the lemur issue, but what we have got is a lot of genetic data that's accumulated very fast over 16 years. We've got old data that has told us that when you look at the reptile colonization of Madagascar, there's a very, very strong South American signal. Here is a freshwater turtle that comes from Madagascar. It is monotypic. It is a monotypic subfamily all on its own. It has no close connections, no close relatives. The closest relative is here, sitting in North America, in Mexico actually. Right. Looking at iguanas, there are no iguanas on Africa, not one. There are iguanas in Madagascar, some, but the major iguana radiation is here in South America. Okay, boas, with boa constrictors, 2 species on the island of Madagascar, tree boa and a brown boa, no boas in Africa, not even any boa fossils in Africa. It's skipped out altogether, and the closest relatives are here in South America. So even when you look at Allosauric dinosaurs, Mojongosaurus and Mojongoponus, that they dug out of Madagascar here, the closest relatives are here in South America. So there's a clear colonization pattern that works for large-bodied animals and small-bodied animals, and it has to involve somehow going from South America through Antarctica and onto Madagascar. What about the other things? Let's look at the other taxa. Birds, ratites, flightless birds. There's only one member of the ratite group, the tinamous here in South America, that can fly. They have an extraordinarily Gondwanan radiation. They look, have always looked, to all intents and purposes, like a Gondwanan radiation that they fragmented with the land masses on which they're currently found. When, unfortunately, you start looking at the phylogenies, the more genetic data you throw in, the worse it gets. The more difficult it gets to understand. And now we're looking at the first, look at the timing of these divergences. The first lineage to diverge is the ostriches at 73 million years. This is way after the Cretaceous breakup. Okay? Then the rhinos in South America, cannot be related? No. Then there we go, the moas, those giant things on New Zealand, they apparently are the closest relatives of the tinamous in South America. That's a distance of what we're talking about, 15,000, 20,000 kilometers. Right? How long did that go to be? Okay, then we look at the elephant birds of Madagascar here. What's their closest relative? I'll tell you, kiwis. Kiwis, 10,000 kilometers away. Okay. And then, of course, the cassowaries and the emus, which are closely related. They never get out of here. They never get out of the Gondwanan distribution. They never get into north here. But somehow they do have an awful lot of ocean rafting to do. This is a very difficult thing for me to understand. So what I want to do very quickly now is talk about the mammals, because the mammal radiation is hugely different from the reptile pattern and the bird pattern. Okay, let's have a look at mammals. There are currently 6 major groups of mammals alive today. These are the ones that have a placenta, these are the ones that have a pouch, these are the ones that lay eggs. Okay? These ones all are Gondwanan. The root of the mammal, the living mammal radiation, is Gondwanan. The only things that are from the northern continents are these 2 groups. Okay, now let's look at what gets onto Madagascar. Africa and Madagascar are split absolutely, finally, last possible time to cross 140 million years. This is the end Cretaceous extinction. So I'm showing here with this blue arrow. Now we look at this. What have we got? What mammals got onto Madagascar? Acrotherium? Yep. We have got 2 Acrotherium groups, some kind of arthropods. I think they're arthropods. Tenrex. That's all we got. Rafting? Hard one, but anyway. Right. What are the others we've got? Lemurs. Lemurs are Euarchonticleres. Rodents. Subfamily of rodents, completely endemic. Euarchonticleres. What else? Pleurotheria, you heard? Hippos, carnivores. This is not the same pattern of colonization that you saw in the ratites or in the reptiles. Okay, Monsieur.
Okay, I showed you a movie earlier on. I want to just show you a couple of bits of times that we know something about, and the complexity of the Indian Ocean is what my main interest is. Here you can see Madagascar in India around about 90 million years ago. There's Africa, there's the plateau that people think maybe things got across into this area via the Kerguelen. There's the Davy Ridge. The Davy Ridge remains a place where it's possible that there was episodic times that it was above sea level, and particularly if we understand a little bit more about sea level rise in terms of what happens to the topography in Africa and Madagascar, and I'll come back to that later. It's a very complicated story. So 90 million years, 66 million years, that's where India is, this is where Madagascar is, that's the Deccan Plateau basalts have come out, that's the Perma-Triassic extinction here, and, Cretaceous-Tertiary boundary extinction. It's not all happening in Mexico with an impact site. This is probably the biggest driver of extinction in the Indian Ocean. That's why I've made it brown there. There's no doubt there was a huge amount of acidification near Stirling. This is one of these large igneous provinces. A huge amount of lava has come out within less than 1 million years, probably 700,000 years. So this is a major event at 66. Indian Ocean sterilization, that's part of the story, part of understanding the story of how and what happened to animals, what died out, what remained, where did they come from. Then 60 million years ago, and remember these areas here, these light blue is an area that are continental plateaus, so it depends again on sea level rise, what happens 60 million years ago. And what I want you to think about is, what was the ocean current like in the ocean when we went from there to there to there? There are huge changes in ocean circulation that we do not understand very well, and of course they have big drivers of climate change. I'll come back to that later. And 55 to 50 million years ago, it connects with Asia, and of course one of the things that we've learned in the very recent times is that this area here between the Reunion and the Seychelles was probably, and we know certainly from geophysics now, that there's a continental, that's continental rock, it's not oceanic. So we're now left with the idea that, hey, maybe it wasn't just across here that things happened, but as soon as this boat landed against Asia, anything that was in Asia was able to jump across and make its way essentially back to Madagascar there. And that is something that I disputed with Judith for many years, and now I've realized that we know so little about the continental rocks in this area, and the new data that has come available in the last 2-3 years makes that certainly a possibility. So that's the simple part of the story. I'm not sure if you have time, but the rest of the story really has to do with understanding the climate change as we move, as we break up that Indian Ocean. And the making up the Indian Ocean is very complicated compared to something like the North Atlantic and the South Atlantic. Very briefly, there's sort of a cartoon of India. That's the ocean currents of India today. That's the ocean. If you understand something about the tectonics of the origin of the Indonesian gateway, the origin of the South Atlantic gateway here between Antarctica and South America, there's a whole bunch of stuff that we really do not know even about the ocean circulation today. How is that affecting the climate? How is that affecting the genetics that comes in via rivers and via these gateways in terms of the biodiversity in the Indian Ocean? So that we know some of these gateways, we know, for example, 56 million years ago, when there is no longer a connection between Antarctica and South America, we know that changes the climate in the Indian Ocean and almost instantaneously. And of course, Antarctica starts becoming an ice. So understanding this is really related to understanding what happens with sea level changes, what happens with climates, with how these continents move around, and understanding what happens. South Africa and Madagascar go up about 2 to 7 kilometers at this time. That is also an issue that we really do not understand, and how that affects the movement of animals and etc. So I'll leave you with this slide here. Madagascar, this uplift here has created a huge uplift in a very tiny place where animals can move from that time onwards. The same in Madagascar. And if you were living in a cave from time to time and the sea level goes up and down, which it does all the time, you have some choices to make from the Cretaceous to the present day. So I will leave you with that last slide. We're starting a new project doing this, and anybody who's interested in that and wants to be part of this, it is part of a whole new project of understanding the Indian Ocean, and maybe also some of the services.